All right, hello back everyone. My name is Ryan coming to you from the DL Academy. This is the continuation of our Python Sudoku solver course using backtracking. Also, if you don't know Python, make sure you go check it out on our website, thedlacademy.com, and use the link for 50% off. All right, so let's get started. Um, this is where we left off at the previous video. We have a Sudoku. We have a function that prints our Sudoku, and we can get all the possible answers at a certain position. So let's create our main function, which is the Sudoku solver. So we'll call it solve Sudoku. This takes the Sudoku as a parameter. It also takes an I and a j parameter. All right. Now let's create an array of arrays. Let's call it mega array, and let's make it equal to a empty list. And this is just to keep track of all our position arrays. So we have an array for this position, an array for this position, and this position, an array possibilities. So we'll have an array that contains all of these arrays. And since it's a global variable, we have to specify it inside our main function. So we'll say global mega array. I explained the global and I explained the global types of variable inside our Python course. We also do recursions and lists, and everything that we're using here is an implementation of our basic Python course for beginners. So once we're started, we can say we can start looping through our mega array. So we can say for, and then let's create a variable. Let's just say b. It can be any name. I'll just give it the name b in range, and then here it's going to be the length of our mega array. So we're going to loop through our mega array, and then if we find an array with our coordinates I and j, that means that we've already been through this case and we already created an array. All right, because when we go forward, if the case or the position is empty, we add an array to our mega array. But first we have to loop through it. We loop through it, and if we find that we've already created an array, we don't need to create a new one. All right, so we're simply going to be using that one to do our algorithm and operations. So we're going to be saying if mega array b, and then here we're going to be taking the second index, which is the position. So we're getting the position. We're saying if it's equal to I comma j. All right, so if we have an array that contains, this means that we already went at this position and we already created the array at this position. So we can say index, we can get the index. Index, I'll remind you, is this right here, this thing right here. So let me just add comments. This is the index, this is the position. So the index is going to be equal to mega array element b, and then here is going to be 1. And then we're going to be creating a new index equals index plus 1. All right, so we're increasing the index because if the array already exists, that means we already went through this position and now we're coming back. So since we're coming back, we cannot use an index that we already used, because this would make the recursion go forever. So all we have to do is say mega array b1 equals new index. So we increase the index, and then let's add if statements. All right, so we're going to be saying if here we say length of mega array be 0. So 0. This is our possibilities list right here. This is all the possibilities. So if the length of our possibilities list is equal to 1, so if we only have one possibility, or length, or this thing right here, same thing here, if the length of our possibilities array is less than mega array B1, which is our index. So basically, let's say here we have an index of 3, but we only have 2 elements inside our array. This also would trigger this if statement. All right. Now what we're going to say is, well, here we're trying to move back. All right, we move back because we don't have any more possibilities at this point. So our only solution is to go back and then try another number for the previous position. So we're moving back. So in this case, we need first we need to get the coordinates. Let's create a variable called coord equals, and this is going to be equal to mega array b, and then the coordinate also is the second one, but we want the coordinates of the previous empty case. All right, so this we go through our mega array, we get the previous element, so b minus 1, and then we get the coordinates for that position. So these are the coordinates we want to move at. We also have to set the Sudoku back to 0. So whatever number we had here, we also have to set this case back to 0 since we ran out of all possible answers, since we ran out of all possible solutions. So we're going to be saying set Sudoku back to 0. Like this, we're going to be saying Sudoku. Let's create another variable. So these are our current coordinates. C equals mega array B2. So these are our current coordinates, and we're going to be saying Sudoku. The first is going to be C0. So these are the I, and the J is going to be C1. This is going to be equal to 0. So this just sets back the current position to 0. And now we're going to be saying mega array dot remove mega array element B. So what this does is, after we're done with this, we're simply going to remove it from our mega array. This way, whenever we come back, we can start fresh, because we get rid of this, we go back, we change this to another number, and then here we start off from fresh. All right, so the array, basically mega array expands and then comes back down, and then we add new arrays to the mega array, and then we remove them whenever we come back, so that we can go and come back and go and come back, so the backtrack can work properly. So this only gets triggered if, as I explained, we have more elements here than our index. So basically, what we're coding right now is whenever, let's say we fill this entire row with numbers, all right, and then we're coming back, and then the program blocks, all right, because we end up to a point where there's no more possible numbers. Let's say we add 4, 7, 1, 6, and then here there's no more possibilities. So this means that either this condition is true or this condition is true. So the only solution is to move back and to get the coordinates of the previous empty case, set this case back to 0, and then move back and then change the case that was before it. So this is it for this video, and we're going to be continuing the program in the next video.